Hello, I welcome you all. The problem reads blocks A and B have masses of 40 kg and 60 kg respectively. They are placed on a smooth surface and the spring connected between them is stretched 2 meters. If they are released from rest, determine the speeds of both the blocks the instant the spring becomes unstretched. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by RC Hibbeler. Right, so of course we know that we are going to be experiencing some weight in that manner, as well as the normal force for each one of these blocks. Right, so this is our WN, NA, WB, NB. Alright, so we are going to use the principle of conservation of energy. What else? We can also use the principle of conservation of momentum. So for momentum, we are saying summation of masses from state 1 to summation of masses times velocity in state 2. So what do we have? So we have ms. So at the very beginning, we are saying they are released from rest, so we have MN VA1 plus MB VB1, and this is just going to be equal to MN VA2 plus MB VB2. All right. So what are the masses? So we have 40 kg. Okay. 40 kg VA1. Okay. Plus. So in this state, at this point here, both this and this are 0 because they are at rest. In this state. Therefore, it is 0 plus 0, which is equal to 14 by VA2. So this is stretched. So expect this to move this direction, the other one this direction. So we'll say plus 16 minus VB2. Okay. All right, so we'll have a 14 VA2, which is equal to 16 VB2. So we have one equation. So using the conservation of mechanical energy, we can simply say there are T1 plus T2, T1 plus V1, T1 plus V1 is equal to T2 plus V2, where T itself is the kinetic energy, okay, and V is just equal to Vg, gravitational potential energy, plus elastic. Right, so what do we have? So when this is stretched, we expect it to have the elastic potential energy. So we have half right, so let's say, so we'll just say T1, okay, plus a half kms squared in state 1, okay, plus so say T1, okay, plus VG1 plus half ks in state 1. This is equal to, then later on we expect some movement, so we'll have half MVA MAVA squared in stage 2 plus half MBVB in stage 2. What else are we going to have? And then we have VG2 plus VE2. Of course, this is 0, this is 0, and this is 0 also, and this one is 0. Right. What do we have? So we have half there. Our K is 180, so it's 180, and our S, the stretch is 2 meters, so we have 2 meters squared. This is just equal to half MA, which is just a 14, and VA, there we go, is squared, plus half 16 VB2 squared, like so. Right. So there we go, we have this equation. So if we wrote this equation in terms of V2, this just becomes equal to, let's write this one, it becomes equal to 60 divided by 40. This is 1.5. This is 1.5 VB2. So we are going to plug in this value. We'll plug it in here. No, not there. We'll plug it in. We'll plug it in here, right? And once we do so, then we'll have, and then we can get rid of these, right? These are common. Then once we do so, then we'll have a 180 by 4, right? Then we can simply say this is equal to 14 by 1.5 VB2. Okay, VB2 squared, right? These are squared, right? And then plus half we cancelled it out already. Then this just becomes a 60 VB2 squared. Therefore VB2 is just going to be equal to, let's calculate this one. So we have 1.5 squared, okay, times 14 plus 16. And we do have a 180 times 4 divided by that, and then later on square root of that. So this we get a 2.1909 meters per second. Right, let me try this again. So 180 by 40 by 1.5 squared plus 16. All right, and then we have 180 by 4 divided by that answer, and then square root of that, 2.1909. So there we go. And this is VB, so we expect this to be moving in this direction, right? And then we have our VA2. What is VA2? So we can use this one here, right? Okay, so this is just 1.5 times VB2, which is just 2.1909, right? And this is equal to 3.2 864. Okay, right, this is B, I mean this is A in this direction, like so. All right, so BA with a smaller mass has a higher velocity, right? So these are the speeds of both blocks at the instant the springs gets unstretched. All right, I think this is about it, and I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.